In Python programming, different data types is an important subject that we need to have basic understanding. We are going to be doing different kind of analysis, saving different kind of objects into variables. So it's important to understand different data types and how each of them apply. Stick around in today's video. We'll be talking about Python data types. Here we have a Jupyter notebook where we've opened up a new project we call Python data types. The first one we'll be looking at here will be the regular text or Python strings. A string. A basic example of a string could be if we have a variable called x, for example. Let us store a string in x. A string could just be something as simple as maybe hello world. And the same way you have a single quote, you can also use a double quotes. They are both the same. So if you run this, let me take this and put it here. If you run this, then you can decide to say, let us find out what type of variable is x. Let's try to find out what type of variable is x. You can see x is a string. All right, so a string can just be a group of letters, a sentence. Let's make this an actual sentence. Hello world, it is sunny today. All right, if we run that and run this, all is still a string. Let's just add a number and see what it gives to us. See, so it is just taken as a sentence of strings, okay? So that is for strings. The next we're going to be looking at will be the numeric data types, okay? The first data type we talked about was a string. The next data type we're going to be talking about will be the numeric data types. In the numeric data types, we have the examples like the integer, the floats, and also looking at what a complex number would look like. Okay. All right. So starting with an integer, let us open up a new block. Starting with an integer. An integer could just be, for example, x could be maybe 10, 100, 5, whatever it is. So let's run this and let's see what type of variable x is. X is an integer, voila. All right. So the next here will be a float, a Python float, a Python float. Let's create a float. Now, an integer was 10, right? But for a float, we'll have to add it in decimals. So it will be 10.0 for a float. So we'll run that. So let's see what type of variable x happens to be a float. Yep. So the next we're going to be looking at here will be a more complex kind of data type. Complex. Let's just call it complex, okay? So now the complex starts with an integer. It could also follow with maybe characters as well. A character as well. So if you run this, you have that. But let's see what type of data structure is x at this point. X is a complex data structure. Okay. So let's add one more. Let's just just as a test. Now, if you do that, you will see you get a different result. Okay. So a complex doesn't take more than the first alphabet. So one letter and one alphabet defines a complex. Okay. So you might be wondering, where is this going to be used? Keep watching, and in future videos, we'll show a simple use case of a complex. All right. So the next data types we're going to be looking at will be the sequences. Let's look at some sequences. Now, under sequences, we have data types like the list, we have the tuple, and we have the range. Okay, let us define a simple Python list. A simple Python list. Now, a simple Python list can be defined with a square brackets. Okay, and in the square brackets, we can put in all the elements that should make up that list. All right. So let's assume we have a ball, a ball. By the way, you separate the different elements of the list with a comma sign, and each of them will be in a quote, either a single quote or a double quote. Okay. So the first element may be ball. Second could be posts. Next could be a jersey. Just something random. So run that. So let's see what type of data structure is X. So X is the list. And by the way, if you are to run X the way it is, you see X will give you the list of items that you declared here. Okay. All right. So the next will be a tuple. Now, a list and a tuple are very similar in the way they look. The difference will be, instead of using a square bracket for a tuple, we're going to be using a regular bracket for a tuple. A regular bracket. Okay. So let's run that, and then let's see what type of data type is X. So as you can see, X is a tuple. But let's just print X the way it is. You see, X gives us a tuple that we created, ball, post, jersey. So let's look at the last one on the sequence type of data types, which will be the range. All right. So let's declare a simple range. Let's say 3. Let the range be 3. So run that. First, let's see what X looks like. So X is between range 0 to 3. Okay. So what type is X as a variable? X is a range. Or a type of data, Python data type, which is called a dictionary. Dictionary. Now, a dictionary is used when you want to map a list of items to a key, all right? And it can be used to also store values, basically, to a key, all right? Now, let us create a simple dictionary. For example, we have something like this. Now, for ease, sometimes we rearrange our code just to make it look easier, okay? So the dictionary starts with the open and close curly brackets. That's the basic you should understand. It starts with the open and the close curly brackets. Now, in the dictionary, you have what you call the keys and the actual item that is mapped to the key. The item could be one single item or a list of items. For example, name here is the key, and the item mapped under name is Emmanuel. Shoe size is also a key. The item mapped under shoe size is 45. Now, if you observe, if you are mapping an integer, you don't need a quote, okay? So let's just add another item here. Another key could be, oh, sorry. Another key could be shirt size. I'm just trying to do anything that makes sense, you know. Sorry, it's supposed to be in a quotation. Separated by a full column. Shirt size could be 30. Or you could just say medium or large or extra large, something like that. You know, just to define something. So basically, that's how you create a Python dictionary. So let's just explore the dictionary and see what we have here. The dictionary as a whole, X is what you have here. Okay. So there you have a Python dictionary. You can also print out a list of keys. You can just go X, which is the name of the dictionary, x.keys, run that, get all the keys. You can see name is a key, shoe size is a key, shirt size is also a key. You can also print out values of the dictionary and a particular key. You can print out the values that make up that particular key. For example, you have 3 keys here, right? Name, shoe size, and shirt size, and you have a dictionary as X, okay? So imagine you want to print out the elements that make up name, all right? So what you will say here, the way you do that is you say X, square brackets. So let's get the actual key. The key is name, right? So I want to print out all the elements that form the dictionary X under key name. And when I run that, I get Emmanuel. Okay, so you can do the same thing for every other key. Do the same thing. I just want to copy paste that, and let me just change the key to another key. So here I'm changing it to changing it to shoe size. Shoe size. Okay. So I want to print out all the items that make up shoe size. And when I run that, there's just one item, okay? And then I can do the same for shirt size and get the same result, okay? So that's just some basics for keys. The next data type we're going to be looking into will be Python sets. Now, when you talk about Python sets, there are actually 2 parts of it. You have a regular set and you have a frozen set. Now, a regular set can be a set where you have certain values defined, okay? While in a frozen set, the values are like what we use the word immutable, meaning that once you create it from inception, you can't change it, okay? Now, there are several use cases for this, but for a regular set, let me just define a regular set. You have a set of maybe apple, banana, cherry. This is just a regular set. And the difference between that and a frozen set, for a frozen set, you have to define it, okay? Like you already have a regular set, all right? So all you need to do is just make it like a frozen set. Just add a frozen set method, okay? So just think about all this coming off. So you define a frozen set, then fixing your regular set into the frozen set, okay? So that's just the difference between the 2. So let me hash this out and hash this on, okay. Frozen sets, okay. So let me run this one and let's see what is X. X gives you the actual regular set. If you try to find out what type this is, it should give you a regular set, okay? Now let's comment this out and let's comment this. So let's run it again. X is frozen set here. So what type is X here now? Frozen set. Okay. Now, the way it is now, a frozen set has been created and it cannot be changed. It is immutable. Now, before the byte array, we have another type which we call irregular bytes, and you have to represent that with a B, okay, so that you can have it in hexadecimal. Let's just assume, you go for something like this. Let's run this. Well, that should pretty much be the same. You run that, and you run type of X. You actually get bytes, okay? So just like what we've done here, let me add a comment here to say that this is bytes. All right, this is bytes. But for byte array, we can just say X is equals to byte array, and maybe just like we did before, 5. And when you run it, you get something like this, okay? So the difference between this and the other one too is, now, first of all, data in bytes can be encoded into binary form and can also be decoded back into a string, okay? So this is very important because it helps in saving this into the memory, all right? So that's one of the use cases of such, and just like when you've created it in bytes, you can actually get a memory view of what you're working on. For example, let's just say you have bytes like maybe 5 like this, for example. Let's run it in the show. Because you have this as regular bytes, right? You can try to get some sort of memory view of this. Memory view. So what this is saying is that this particular byte was saved in this memory, all right, in this location, okay? But let's just see if I run it again. So you see that the location changes, okay? Each time I run this, it saves, and as it saves, the location it saves changes, okay? So that's it for today's video, talking about Python data types. Subscribe if you've not yet subscribed to this channel. This helps us grow our channel to reach out to more people and tells us that you appreciate what we are doing and encourages us to keep on doing what we're doing. I'll see you in the next video. Bye.